Hello everyone, so welcome to my channel. So today's topic is 48 volt BSG system. So nowadays you might have seen many terms like electric vehicle, BEV, mild electric vehicles. So all these things are going right now in the market, and we will see what is this 48 volt BSG system. So going forward, so the topics which we are going to cover, that first we will understand what is the basic of the charging and starting systems, how right now we are using the charging and starting system, then only we can understand the BSG. So BSG is nothing but the belt starting generator. So we will see what it is, okay, and why we use the 48 volt only, why we are not using 36 8 volt or 60 volt or 80 volt. We will see this thing. What are the features of BSG system, then what is the operation, how it performs, what are the different architecture in BSG, P0, P1, P2, all these things you might have heard. Then 12 to 48 volt adaptation, then you will see that what is the 12 volt BSG and how we are adapting from the 12 volt to 48 volt. Then what is the topology of 48 volt, and then merits and demerits, what are the advantage and disadvantage of using this. Then start stop system, that is the introduction. So BSG, what would be the features through the BSG will be coming. So we will see these are the start stop system, or auto switch off engine and restarting. All these things are the part of the BSG. So we will see the components of a start stop system, how it is work, then what is the auto switch off the engine, then auto restart engine, and merits and demerits. So we will try to cover these things also, but first we will see what is the essence of this BSG system and how it works in the system. So going forward, so the basics of charging and starting system, if you see the charging system, you right now you people see that what is the purpose of this charging system. So charging system is nothing but it supply the current to all the loads, and it store the charge also. It store the charge where? In the form of battery. So charging system is nothing but that supplies the current demands made by all the loads. What are the loads? Your lighting system, your accessories, okay, headlamp, okay. So all the demands, rear wiper washer, okay, windshield, all these demands done by the loads in the form of current comes under the charging system, and charging system should be that much capable that it meets all the demands made by the loads and store the charge. Store the charge means that it should store the charge in the battery, okay. So this is your charging system. So charging system is nothing but a alternator. So this is your alternator. So what it does, it produces the current, okay, and charge the battery plus demand made by all the loads. So this is the function of the alternator. So alternator is doesn't do the kinetic energy to the electrical energy, okay. So you might be aware of this, that there would be one belt and we will be having the engine here. So engine rotates and this also rotates, and you know the basics of how the electricity generates through rotation, okay. When permanent magnets rotates, and all these basics I hope you are aware. So you just understand that what does alternator does here, okay. So this is the charging system. Now coming to the starting system. So starting system is nothing but actually what it does, it is used to crank the engine. So in starting system, what is the component? Your starter motor. Starter motor is the component which is used to crank the engine. So you know that for cranking the engine, there is a, you know, rotation required. That minimum rotation is provided by the starter motors. How much minimum rotation is required, you know, and how much is the gear ratio? All these things we will discuss in detail when we will see the product development, how the starter motor is developed. Okay, but as of now, you just understand what is the function of starter motor. Starter motor motor used to crank the engine, and how cranking of engine is happening to provide the minimum rotation. Okay, what is the minimum revolution, that we will discuss in detail. Okay, depends on many things. How? So this is your uh, if I see, sorry, if I see the, you know, circuit, if I see the circuit, so this is your battery. Okay, this is your negative, this is your positive. So you have the solenoid, this is your starter motor, and this is the, you know, flywheel. This is pinion. Okay, this is your control circuits, this is your ignition switch, and this is a starter safety switch. So you know the function of this starter motor. Now we will discuss about the ignition switch. So in ignition switch, there are, you know, different positions. One is low, then off, run, start, accessory. So in low condition, what will be happening? All the circuits are open and steering wheel is in lock condition. Okay, lock position. When it is off, then what is happening? What is happening in off position? So circuits are open. That is, sorry. Circuits are open. Circuits are open and steering wheel can be turned and key cannot be extracted. Then run position. Okay. So in run position, all circuit except starter circuits are closed. In start, power is supplied to the ignition circuit and starter motor only at instant. Okay, in that instant. When it is in accessory position, then power is supplied to all but not to the starter or ignition circuit. So these are the five, you know, positions of the this key switch. We will discuss this in detail. What is the function and how what is the meaning of all circuits are closed except starter circuit, and power supply is supplied to particular circuit or not this. Okay, and then accessory is on. So you might have seen when you know, put the your key in your vehicle, and then you see when you rotate in a one point, then your accessory are able to, you know, you can on off those accessory, but on first position you are not able to do anything. Okay, so these things we will also, you know, discuss. If you want, you can comment below on the video, and I will make. So I hope starter motor is, you understood. Alternator you understood, but you see that starter motor is in this position and alternator is in this position. Okay, so if you and ignition switch is this, charging system light, this is your main fuse box. So I will tell you how many types of fuse box: main fuse box, or we are call it primary fuse box, then secondary fuse box. Okay, all these I will explain. Then this is your battery. So one thing you might have seen, that starter motor is used only to crank the engine. After cranking the engine, the pinion, right now it is engaged, then it will disengage. Okay, it will disengage because you cannot rotate with this flywheel of the engine, because engine RPM is higher, and you might have seen many times, due to, if it is engaged in the running condition of engine, then your starter motor is gone or damaged. Okay, so you understand one thing, that starter motor is used to crank the engine only. Okay, then it becomes an ideal part of the vehicle. Once it is started, it becomes an ideal part. There is no use after that. Okay, and alternator is used when your engine is started. Okay, because alternator can work when your flywheel, this pulley is rotating, then only it can work. It can generate the electricity. So one thing you might be understood, that starter motor is creating a extra weight, and it becomes idle when your engine is started. So you can see right now that alternator is here and starter position is here. Okay, this is your belt, this is your engine, this is your flywheel, then clutch and gearbox. So one thing what in BSG is happening, that right now situation is, existing situation is, alternator and starter are independent. Okay, and a starter motor becomes idle once your engine is started. So what is thought process here, that this machine which is generating the electricity, that we will make in such a way that it can start the engine plus it can generate the electricity. So what will happen by doing this much? So your one component can be reduced. Okay, so there are devices, there are e-motor devices which can start the engine and then start generating the current. Okay, so we call it BSG, belt starter generator. Okay, belt starter generator. We will show what are the, how it works, and what is the process of doing this one. So we will see that all these things in details. So I hope you understand the what is the existing condition and what we are trying to do in with the BSG or ISG, integrated starter generator also we call. Okay, so here I just show you that this is our battery. So main negative earth on the starter board or negative terminal. Okay, so this is your the 40 square mm, how and why we are taking the 40 square mm, all these things, how to select the wire all these things we will discuss in coming slides. These are the ignition switch positions. Okay, this is the your solenoid. So I hope that you understand the basic of charging and starting system. I will go further in the BSG, because I cannot go into much deeper right now because we have to cover the BSG and ISG. Okay, moving to the second slide. So BSG is nothing but, as it mentioned, that belt driven starter generator. So what is happening here? You can see here the concept which I have told you. Before that, alternator is was here, and uh, yeah, sorry. This alternator was here and starter motor was here, near to the flywheel. But now if you see, the belt starter and alternator are combined in one device or one component. So you understand what it does. This particular device is doing both the function, starter and alternator, and this device is always engaged, and it is like in first case starter motor was engaging one time, and after that it was it is idle. But now you can see that it is doing the both the function. This is your belt, this is your starter generator, and this is your engine, this is flywheel. In previous case, our starter motor was here to engage with flywheel so that it can start your engine, then clutch and then gear. So I hope what is the belt drive and starter generator you understood. But before going to that, I will tell you there is a, in the beginning of this video I have told you the terms electric vehicle, plug-in vehicle, hybrid, full hybrid, mild hybrid, macro hybrid. So I will tell you based on which factor they have you know segregated these things. So this is e-motor power, and this is your CO2 saving potential in NEDC. NEDC is nothing but is a European standard or agency which used to control over this, gives the data on this. Okay, so 12 micro hybrid, sorry, when we are saying 12 micro hybrid, when your e-motor power is providing the power less than 5 kilowatt, then we are saying it is a macro hybrid, and it gives the saving around 3 to 4% of the CO2 saving. And here the system is volt stabilization system voltage. Then we come into the 48 volt mild hybrid we call, and here we get the power from 5 to 15 kilowatt from the e-motor, and 13% of the saving of CO2 saving we can see. Here we use the 48 volt DC-DC converter, 48 volt belt starter generator. This is the segment which we are going to study. I hope you understand. So we are going to study 48 volt mild hybrid. So whenever someone is saying that this is 48 volt mild hybrid, then you understand that there is a 5 to 15 kilowatt of e-motor power is provided, the energy is provided by e-motor, and the vehicle is saving around 13% of CO2. Then we come to the full hybrid, which is saving around 20 to 40 kilowatt and 20 to 30% of the CO2 saving. It comes into high voltage power electronics and high voltage drive axle. Then plug-in hybrid, which is saving 60 to 120 kilowatt, giving the e-motor power is giving 120 kilowatt, and 50 to 75% of the, it also comes under high voltage. Then you know that electric vehicle where you don't have the ICE engine, okay, your whole vehicle is driving on the motors, okay, and you might have seen that there is a battery pack coming in the range that 107 kilowatt, or 100 kilowatt, or 90 kilowatt, or 80 kilowatt you might have. So it provides the e-motor power, provide the 60 to 150 kilowatt, and 100% it is saving your the CO2. I would not, this is a debatable question that whether we are saving the 100% CO2 saving or not. That is debatable. I will not go in that way. But as of now, we are just saying based on the, if you are using the motor, then this is only motor, then you are saving the 100%. If you are using IC engine plus motor, then we are saying full hybrid, plug-in hybrid, mild hybrid, and 12 micro hybrid. And your CO2 saving also is not 100% due to you are using the IC engine. Okay, so what it is written here, I have written the comments also. So whatever I am explaining, this is the same thing, that polluted city hybrid and EV vehicles become necessary. A large number of Cummins OEMs with the mild hybrid vehicles. There are two types of system which I have already told you: 12 volt system and 48 volt BSG. So 12 volt micro hybrid, 48 volt mild hybrid. Features of mild hybrid: belt starter is nothing but a smart motor alternator device where you have the motor which I was telling, and plus alternator also. So it is driving your flywheel also to start the engine, plus it is generating the uh, current also for your loads and battery. Then BSG assists the engine while acceleration, okay, because it is producing some power, right? And that power, it can be stored and it can be used to accelerate during the you know when you are speeding, okay. Enable the start stop function and converts the kinetic energy of vehicle into electricity during deceleration. So what does it mean? That is nothing but regenerative braking. This is nothing but regenerative braking. Moving forward, I hope this slide is clear. If you don't have any doubt, you just write down below the video. I will clarify there also. Then your question would be like, why you might have seen that 48 volt 48 volt, then you might have seen 12 volt. Your question would be like, why we not using 36? Okay, you might be aware that we can use the multiplier of this: 12, 24, then 36, then 48. I hope you know this particular thing, that 12 volt we are using the passenger, 24 we are using the commercial vehicle, okay. 36 we can use, but we are not using, we are going just with the 48 volt, okay. So due to the cell voltage, we are using in this multiplier form, okay. I hope you know this thing. If you don't know, you just comment below the video. I will give the answer why we are using the 12, 24, 36 and 48. Okay, so you might be aware why I am not going 60 volt, why I am not going to 80 volt, why only 48 volt. So the reason is here. So till 24 we consider it low voltage. 24 to 36 volt, this we call restricted operation. Then 36 to 52 volt we give it the full performance. And then above this is also restricted, we cannot use, this we cannot use. And 54 to this high voltage measures, okay, here you cannot. And then above the 60 volt we consider everything is high voltage above 60 volt, okay. So you will might be asking that from where this data came. This data came based on the study, based on the analysis. After so many experiments, this data came that this is the range of normal operation. If you are putting above this, so there is some issue in this particular range. There are some issue, or there are definition that above 60 volt um, we consider it high voltage, okay. So here I have written the same thing. The selecting the faulty volt as a nominal value, the safety and efficiency. These are the two most important factor which we have considered. If you are going above 60 volt, then you have the issue of safety and efficiency. Safety means then if you have to give the extra component or more insulation to your system to avoid the high voltage risk, okay. So this voltage provides the additional power without drifting into high voltage domain. So above 60 voltage everything is called high voltage, and if you are drifting to the high voltage you have to give the insulation as like that. Limit of 60 voltage is to upper safety maximum before battery voltage is considered too dangerous. If you are going above 60 volt, then it is considered as a dangerous. Normal operation is achieved in the range. However, electronic component within vehicles should be able to withstand worst case high voltage condition, okay. Anything higher than 60 volt not only breaches the SELV. SELV is nothing but safety extra low voltage, but becomes more expensive to implement. So suppose if you are going beyond the 60 volt, it is like why you are not using 80 volt, because it will not be relevant in two terms. First, safety, okay. Second, if you are going to implement this thing, that it becomes more expensive, which is not affordable. The main purpose of 48 volt battery is to provide the additional power demanded by power hungry application, as well as reducing the electric current throughout the system. So it is reducing the electric current also. So I hope you know P is equals to VI or V is equals to IR. Okay, if you are increasing your volt, okay, then your current will be minimized, okay. So this trick allows the smaller cable cross section to be used, massively cutting amount of the copper in the 4 plus kilometers of wiring in today's high end, and therefore enabling significant weight and cost reduction. If you did not understood this concept, how if you are using 48 volt or 12 volt, in this the current would be less, in this current would be more. If current is less, cross section would be less, okay. If 12 volt current is more, okay, then cross section CSA would be more. And if CSA is less, then these two things will happen: weight and cost reduction. I hope you understood this slide. If you have not understood anything on that, please comment below. I will explain again. Going down to the next one, then what is the BSG feature? So I already told you this is mild hybrid electric vehicle. That alternator is replaced with BSG. What is controlled BSG replaces both conventional starter and alternator with a single device. What it will do? To eliminate the starter, which is only a passive component during the engine operation. So I hope already I have explained this. What does it mean? This is passive component that replaces the present belt and pulley coupling between alternator and crankshaft. Okay, to provide the fast control of generator voltage during the load dumps. So BSG have three important feature. By you have the 148 volt extra power, so which can enable your start stop function, electricity generation and power assistance. So electric power generated during regenerative braking charges the 48 volt battery, which in turn reduces the fuel consumption and it reduces the CO2 emission. So as I told you, so 12 volt and 48 volt. So we are keeping 12 volt battery and 48 volt. So here we are discussing about 40 volt. So 48 volt battery we have the extra, right? Okay. So this, if you have the extra power, then what you can do, you can give to some functions, okay, like lighting and other things. If you are giving this 48 volt to other functions, then because your alternator is running through engine, and if you are giving this power to other, then engine load will be reduces and therefore the resultant CO2 emissions. So going forward, so how it is happen, so BSG operation it is explained. As a engine is switched off every time we come to stop and fuel is saved, while accelerating BSG supplement the engine torque e-boost function thus help to reduce the fuel consumption. While it draws energy from battery to accelerate, it also restores the energy through regenerative braking during the deceleration. So regenerative braking, if you don't know, just comment in the below. I will tell you regenerative braking is nothing but during the braking, this kinetic energy regenerative braking during the acceleration. So we will understand this function through the graph. So this is the time and this is your vehicle speed. So suppose your engine is auto stop. Okay, restart of the engine with ISG or BSG technology from here. Then when your speed is increasing, then what will happen, that you have the e-motor. E-motor will assist, okay, to the vehicle during the acceleration. So that what will happen? It will limit the fuel consumption and reduce the engine load, which I have already told you, because your alternator is connected through engine. So if you have the extra power, then your loads on engine will be reduces. And when it is going to deceleration, then through the regeneration during the deceleration, that is called regenerative braking. So this is how the whole function of BSG works. So in the initial phase, that restart of engine with the ISG technology, then during this e-motor will help to the engine to reduce the load, and the power will be given to other accessories also. Then during the deceleration, that regenerative braking will be used, and by that uh, the power will be stored into the battery. Then going to forward, then BSG architecture. So as I already told you that there are two types of architecture. Oh, sorry. That one is 12 volt BSG architecture, other one is 48 volt architecture. In 12 volt architecture, single battery system lead acid and dual battery system lead acid plus lithium ion, or lead acid plus lead acid. Okay. So single battery architecture is used in vehicle like Maruti Suzuki. It uses single 12 volt 70 Ah enhanced flooded battery which support the vehicle electric load as supplement engine the engine torque during the acceleration phase. So which we have already discussed. Then dual battery. In dual battery system used a vehicle like Suzuki Baleno ISG UK market, it uses 12 volt 50 Ah conventional flooded battery which support the vehicle electrical load and BSG start stop function in combination with 3Ah. There would be one more small, one would be 50Ah, other would be 3Ah lithium ion supporting the further BSG load, torque assist and recuperations. Okay, so one battery would be here, okay, and one battery would be here. In this, only single battery would be there. Okay, so this battery would be 50 Ah, okay, and other battery would be 3 Ah lithium ion battery. So this is the whole architecture of 12 volt. So we are not studying the 12 voltage, or we are not discussing the 12 volt BSG architecture. We are discussing about 48 volt BSG system architecture. So we will see the 48 volt BSG system. So in this, this is more a complex architecture. It includes two different system voltage. One DC-DC converter is required to balance the load both sides. Okay, so you know that we have already one 12 volt battery, but you are keeping one 48 volt battery also. So to distribute the load, power to the other loads, you need one DC-DC converter so that it can equalize. Auxiliary loads run on the 12 volt battery, while power intensive load like 48 volt BSG, electric turbocharger, electric chassis run on 48 volt grid. Okay, so if you see like air condition, engine cooling, BSG, here your inverter, motors, so is assume PTC, EPS, 12 volt battery, DC-DC, 48 volt. So here if you see the architecture, you have the 12 volt, then your 12 volt loads, headlight, AC blower, infotainment, power window. These are running on this. Then you have the DC-DC converter, which will give to this battery. And then you have the e-motor, inverter and motors. So this will be given to for the BSG functions. Okay. And 48 volt loads like electric steering, air condition, engine cooling. Okay. Heated windshield, PTC heater, all these works on the 48 volts. Okay, I hope you understood what is the concept in this. And if you have any confusion on this, you just ask me. So there are different company have different. So this is the second generation 48 volt, architecture. In this, what they are having, electric motor generator start. So this is the one which they are talking. Start engine during the stop-start operation and provides some power to the wheel. Later, it charges the battery also. Okay. Then e-charger. E-charger is this one. So e-charger is nothing which provides the boost while driving away from the stop and complements the exhaust turbocharger and eliminating the turbo lag. This is a different architecture, but having the BSG architecture. So the 48 volt system, what it is having, 48 volt inverter changes the DC battery current to AC current to power the electric motor, which we have seen earlier. This is the one. Okay. Then 48 volt lithium ion battery that stores the energy regenerated during the braking, used later to power the vehicle. So this is nothing but this 48 volt. So what it stores the energy and later it can be used, and it is done by regenerative braking. Then battery controller, of course, it would be without this, it cannot be. It regulates the state of charge into the battery. Then power distribution box, so which I already discussed. So power distribution box is nothing but you have the fuses, okay, you have the relays. Okay, we will discuss this thing in detail, how to put, you know, how to select the fuse box and what is the role of relay, what kind of relay you should select. All these things we will discuss. Then 12 volt system, that is the nothing new, that you DC-DC converter, you have this one, fifth one, and it gives to the, changes the 48 volt to 12 volt, and then 12 volt battery, that is nothing but that is our old, the 12 volt electrical distribution that power the center console, seats, windows, as well as other 12 volt devices. So I hope you understood the system and what is the function of each and every device. What is the battery controller? What is the 48 volt inverter? What it is doing? What is the 48 volt lithium ion battery? What it is doing? How it is used? Battery controller, what is the function of? Power distribution box, why we are using? Then DC-DC converter, then 12 volt battery, that is nothing but the old one. Then your 12 volt electrical distribution system. What does it mean? That you have to, you know, give the fuse box in that such a way that that some of the loads will go on 12 volts, some loads will go on a 48 volt system. I hope you understand this. Going forward, then what is the adaptation? So 48 volt, sorry, 12 volt to 48 volt adaptation. What is this? This is your combustion engine. Then you have the generator, which I have already discussed. Then you have the 12 volt battery. Okay, this is belt, this is your clutch. This is our conventional. Then what they are doing in 12 volt? They are putting this inverter, BSG, okay, belt starter generator. Then this is your old one. And here they are putting the DC-DC converter to give the, to charge this battery also. Okay, and you have the 48 volt, this battery also, which is also charged by here only. Then you have the, when you are putting all this BSG here, this is called P0 implementation. So there are different architecture which we will discuss: P0, P1, P2, P3, and all these architecture we will discuss based on the location of the BSG. These architectures are defined. So what happens? This is your 48 volt battery. Then this is your 48 volt load. You have the DC-DC converter for 12 volt battery so that you can charge and give the loads. Then you have the DC to AC inverter, and this is the inductive motor. This is your combustion engine. Okay. So it gives to this also, because you have to run the motor also, right? If you don't give this DC to AC inverter, then your motor cannot be run. Okay. If you are giving the AC motor, because we are using the inductive motor here. Okay. So there are reason why we are not using DC motor here, why we are using inductive motor. All these things are there. So all these things are, after experimental data or analysis, then only these things are coming. And going to the next slides, so which I have already discussed, that there are different topology of the P0, P1. So in P0, which we have already discussed, so this is your combustion engine, this is front, this is rear, then this is your combustion engine. So in this, it is mounted here itself, so provides higher torque than P0 architecture. So this is your P1. So if you are putting this BSG system and motors here, then what it will be, it provide the higher torque than the P0 due to the absence of belt drive. So here we are removing the belt drive itself. So with no belt losses, there is a greater efficiency. The maximum power is required is 10 kilowatt. Okay. Then P2, P3, both P0, P1 architecture are mounted on the engine. So here also it is mounted on engine, here also it is mounted. But there are other mounting options, such as having 48 volt electrical machine on the gearbox itself, input output shaft. Okay, if you are putting the input shaft of gearbox, that is called P2. If you are putting on output shaft, then it is called P3. So this translates to improved energy flow efficiency and allow the provision of hybrid function, e-drive. The P2 architecture is either into transmission on input shaft or attached on the side, and results in the increased energy repercussion and electrical drive capability. The mounting solution of output shaft P3 provides highest level of above mentioned benefits. The obvious disadvantage of shaft mounting, the cost of integration. The cost of integration here, it is not that much easy. Okay, you need a specific, calibration, and each and everything you have to do from the scratch. Okay. Then there is a one more mounting position is this, that is P4. Okay, we have seen P2. Okay, between C0 starting clutch and decoupler, we have seen P3. Then we are seeing P4. In P4, what it is, the ultimate architecture at this time involves mounting at rear axle drive itself. Okay, this provide vehicle with 4WD capabilities. Okay, with the combustion engine at the front and electric machine at the back, maximum power requirement of P2 P4 RG can reach up to the 21 kilowatt with an efficiency of 95. So you can see, okay, but the cost would be the highest in this P4. So P0 क्या है? Cheap है. This is cheap. Limited efficiency due to belt losses. P1 crank mounted on crankshaft, restrict to the length of axis. P2 drive on gear, box input shaft, integrated with the starter generation, more expensive, no drag losses, engine less cost efficiency, functionality, costing. P3 drive on gearbox output shaft, enhanced P2 capability. P4 highest potential for repercussion. Repercussion nothing is regenerative braking. Okay, moving to the forward. So these all the things you can read. I have already explained what is the position. This is front, this is P0, this is P1, this is P2, this is P3. Okay, this is your P4, the rear. Okay, what are the advantage, disadvantage? Here I have written, you can go through one time. And this is your belt starter generator, sorry, here. And this is your electric supercharger, which we have shown. I have one video, I will just show you, then we can wind up this video. This video from Value. You can go through the website also and you can search it there. So you might have seen all the operation in this video. This is very beautiful video where you got all the idea about how this one unit is doing everything, whether it is starting and generating the power. So merits and demerits already in this last portion of this video, it has been seen, but I will go one more slides. So here 12 volt BSG and 48 volt BSG. So what are the advantage and what are the disadvantage of this? So advantage, no require mandatory DC-DC converter because you have the 12 volt on other side also. For a small system, 12 volt is convenient because 12 volt DC load can run directly from the battery. 7 to 8% uh, improvement in the fuel economy, cost effective. Disadvantage, at the 12 standard, the 14 volt charging at 300, maximum of 3 kilowatt power is available from a motor generator, due to which e-assist regeneration function is limited and hence low recuperation power. So which I have already told you, if you are having low, then all other things, things would be low only. A advantage, 48 volt grid, 55 charging at 300, maximum of 64 kilowatt power is available from the motor generator for enhanced e-assist and regeneration. DC voltage remains below the safety critical level of 60 volt, which I have already told you what is the reason we are keeping this. High recuperation power, 15 to 20% improvement in fuel efficiency. Need of DC-DC converter to connect 48 volt to 12 volt. This is the disadvantage, which is good in the this 12 volt. You don't need 48 volt lithium ion, which is costly, of course. Depending on battery size, separate battery cooling arrangement is required. So all these things which we have already discussed, and advantage and disadvantage, you can see. If you like this video or you don't like this video, please comment and tell me where we can improve and can give you the better solution or better material or better content to doing your help. Thank you very much.